So it's exercise 2C, question 7. What I want to look at now is just going from a very wordy problem into how do you go about solving it. So I'm going to read the question out in a minute, and I'm going to do what I would do if I was in an exam, as I read the question out, how I would write these actual things down, and how I would start to answer the question, although I'm not going to finish answering the questions. So question 7 says, the TQ company makes a soft drink sold in 330 milligram cans. The actual volume of the drink is normally distributed with a standard deviation of 2.5 millilitres. I don't know what the mean is. So I will have V being the volume of drink in can. And I said that V is normally distributed with an unknown mean and a standard deviation of 2.5. And then remembering I write the variance in here, so I'm putting 2.5 squared, and cans are supposed to hold 330 millilitres. Right, that's the first paragraph dealt with. Second paragraph. To ensure that at least 99% of cans contain more than 330 millilitres, find the volume that the company should supply in the cans on average. So if I've got to find the average volume, I've got to find mu. The average is the mean is mu. So if I read through that sentence again, it said, to ensure that at least 99% of the cans, so it's 99% or more really, 99% of the cans contain more than 330 millilitres, find the volume that the company should supply in the cans on average. Right, I want to write some sort of probability statement down here though. How can I turn that last sentence, these key facts here, into a probability statement or a probability question?
Would it be P bracket X?
I'm using V, but
V.
yeah, okay.
Is greater than 338 equals 99 or 0.99.
Yes, okay, that's the key thing. We want to set the probability that the volume is 330, or the Billy principle, we could even put an equality sign there, 330 or more, because it makes no difference, is at least 99%. So we could say equals to, because that will give us our critical value, or you could put greater than or equal to. Yeah, if we solve it for equals 0.99, that's correct. So now if I look at just what we can see on screen, I'm only really interested, to be perfectly honest, in that line there and that line there. Everything else written down, and the V line, I only need my definition of V. So if I cover that line up with a pen, that is everything I actually need to answer the question. But that is how I would be writing it down in the exam. Yep.
In the exam, would we lose a mark if we didn't put like X equals?
Yes, possibly. But yes, you should state your variable. So yeah, this line here. Okay, yes, I ought to arrow that one as well. You ought to make sure that line is down there, so they know exactly what you're talking
What if
about.
they just give you a straight X and just ask them to work it out?
Then that's fine. It's not up to you to define it. That's fine. Okay, how would we go about starting this question? What would the next thing to do be?
1 minus.
Yeah, that's a greater than. Don't like greater thans. So turn it round so it's a less than or equal to 330 equals what?
Minus
0.0, yeah, 1 minus 0.99, which is 0.01. Can we go from there straight into the phi notation? Can we go now straight into phi of bracket equals? What's going to go in the bracket?
338.
Yeah, my x, or here my v number goes there. Then what happens on the top of this fraction?
Minus mu.
Minus mu, which I don't know,
2.5.
over sigma, my standard deviation, which is 2.25, equals 0.01. Okay. Now what?
Anti-phi.
Anti-phi, yes. Okay, I want anti-phi, which basically means on the left you just write it out again without the phi. You will anti-phi, which we'll do is phi to the minus 1, and that is regular notation, that's not Mr. White made it up notation. Okay, anti-phi 0.01. We look in our tables to find 0.01 in the middle, and what?
Is it not on?
So, yeah, it's not in there. So, how do we deal with anti-phi 0.01? Because all the numbers in the middle of our table are bigger than 0.5. We had a red box rule from last time.
Minus number of 0.99.
Say that again, Billy, please.
The minus number of 0.99.
The minus number of 0.99, yes. You do one minus in here and stick a minus at the front, okay? So we will be doing anti-phi of 0.99 and sticking a minus sign in front of it.
Do you still have to leave the minus 1?
Yes, we're still anti-fying there. Yep, okay. Well, I said we weren't going to finish this question, we might as well do it now we've got this far. So can you anti-phi 0.99? What row is it going to be on?
2.3.
Maybe choice 4.
Choice of 4 numbers.
Yeah.
What do you reckon it's going to be? 2.3?
2.32 plus either 12.
Right, no.
7.
Okay, 2.326-ish, okay. Now just look elsewhere on your tables. Is there actually anything we haven't looked at yet in the tables which could be useful here? Hint, something we had, yeah, down the bottom, that's right, okay. Down the bottom, you have some anti-phi-ing going on in this very small table down here for special probabilities, numbers that crop up a lot. So if we're anti-phi-ing 0.99, we get 2.326, that's what they're saying. So the bottom table down here is an anti-phi table, basically for 75% or 25% if you think of it backwards, 10%, 5%, 2.5%, 1%, 0.5% and stuff like that, okay? So for particularly common values, you can use a table there. So that was 2.36, we need to put our minus sign in there.
Would you put a minus on the bottom ones if you had a minus as well?
Yes. Okay, so we've still got our minus sign here, that minus sign just drops down. Anti-fying 0.99 we got from the table at the bottom. And then it's just a case of rearranging that to find out what mu is. I will stop it at that point because that's just year 10 maths. From there on, rearranging that and solving that one. Okay? If you want to check your answer and finish it off at home, the answer will be in the back of the book.